Hi everybody. Just kind of going through these videos and whatnot. Um, I'm making the decision to not use my iPad because everything I would write down is already on the video note, or not the video notes, but the notes that I do in class. And I don't want it to be redundant where you're watching the video and you're just watching me kind of go through all the notes and stuff like that. Um, so instead, what I'm going to do is I'm going to use Excel because I'll be very blatant and honest. If you have a yellow calculator, way easier to use a yellow calculator. It's the TI 83. Um, and if you do have one, I would Google how to do T confidence intervals and then T tests. Um, but a lot of us are just taking this course, because we're trying to get it for our degree and whatnot. So instead, what I want to do is I kind of want to show you how to do this in Excel. And what I would be doing in Excel, okay, the real reason why I'm not getting my iPad out is because I'm just going to build out a lot of these problems in Excel and kind of go through the step-by-step process of how I would do it. There isn't a convenient, excuse me, there isn't a convenient function to kind of pick out. So instead, what I'm going to do is I'm just going to kind of use Excel. I'm going to build out the confidence interval that way. And then I'm going to do a significance test using the same type of data. But the one thing with a significance test, you have to be given a certain type of information. So let me share my screen and we can get started. So I'll start with this and then I'll work my way over. So the one thing about confidence intervals, okay, for a t-distribution, and I believe we used a formula very, very similar to the standard error for a normal distribution where we divided by the square root of n. The difference was we had the population standard deviation in that case. In this case, we're going to be using the S, which would be actually the sample standard deviation. But what it does is it gives us a standard error of X bar. And eventually what we're going to do is we're going to build out our confidence interval the same way that we did it in the last couple of chapters. Okay, or modules, I should say. So used to chapters. And we're going to start, okay, by doing X bar plus or minus T star times the standard error of X bar with T of n minus 1. Okay, now that seems kind of somewhat confusing. Okay, but what I want to do is I want to go through, all right, in an Excel document with a data set, with a data set to kind of work off of. So I just made up a bunch of random numbers, okay, kind of going from 1 to 25. What we could call this data set, I've got 11 here. Let me get up to 15. Let's go 25. Let's go 5. Let's go 13. And then 12. So just give me up to 15. Yeah, beautiful. It gets me up to 15. And let's add a label so that way we can kind of give some context to this data. This is a sample of purchases at McDonald's. I'm just making it up on the fly here. So what ends up happening, okay, this is every time, we've looked at 15 customers, okay, we're not up to the 25, but it's okay because we're using that T distribution. And what I want to do is I want to create a confidence interval that represents the lower limit of what, the lower limit of what we would expect the population to purchase at this McDonald's, and then an upper limit of what we would expect, that highest group to order at McDonald's. So if you have the data, okay, so what we're going to do is we're going to start out with S equals, okay, remember this is your standard deviation, okay, and I'll kind of, yeah, good. All right, so what I'm going to do is I'm going to do standard dev, okay, in Excel. And then what I'm going to do is I'm just going to highlight my data. Now, the one thing I do want to be very clear about is when you're doing this, if the question already gives you, okay, all of the numbers and things like that, you don't have to do all of this because it already gave you all of the numbers necessary. We've done a lot of problems like that. What I want to do is I want to start working on based off of data sets. Okay. And some of your questions will go back to, okay, here's the given data. Go ahead and apply it using the formulas given. That's very similar to what we did before. Again, I don't want the videos to be redundant. Okay. I'm going to do one based on a data set. So now what we're going to do, okay, is we're going to start to build the standard error formula. Okay. Standard error of X bar. So the standard error is when we take the standard deviation divided by the square root of n. Okay. And that's exactly what I'm going to do. I'm going to take this value, I'm going to click it, and I'm going to hit divide, and then I'm going to type in the square root, and I'm going to say 15 because I have 15 samples. And that's going to be my standard error right there. Okay. My standard error is 1.35177. Okay. So now what I need to do, okay, I've got my standard error. Okay. If I go back to my notes, I can see standard error right here. Now, if I want to go to my confidence interval, I can just see right here quickly. Okay. Standard error of X bar times T star. Okay. Well, in order to do T star, this is the new stuff. Okay. So what I need to do first is I need to understand, okay, I need my degrees of freedom, okay, which is going to be T of n minus 1. Well, I know that my sample size is 15, which means I am now looking at 14 degrees of freedom for this problem. So to find T star, okay, if we want a 95% confidence interval, that will be given. It's always got to be given, as you saw in the last chapters. The 95% confidence interval, we're going to use T star. And what I'm going to do is I'm going to go to this table that I'm going to upload. Okay. And what this table shows us is for a 95% confidence interval, when I have 14 degrees of freedom, I'm going to go up and then I'm going to look at 14. Okay. And my T star value is going to be 2.145. Okay, so 2.145 is what I'm using. I'm sorry if you're getting dizzy. Keep going back and forth, right? 2.145. And again, that value was used using both the degrees of freedom and then the fact that I'm using a 95% confidence interval. If, for example, I was using a 90% confidence interval, what I would do is I would go down here to the 90. Then I would go up to 14 degrees of freedom, 1.761. That's the value I would use, but I'm not. I'm using a 95% confidence interval, which means I need to use the T 2.145. Okay. So now that I've got that, okay, I have everything I need except for the mean, and I'll talk about that in a second, to build out this formula. So what I'm going to do is I'm going to do X plus T star times the standard error of X. Okay. Then I'm also, because it's a confidence interval, I'm going to do X minus T star times that standard error of X. Well, I don't have X. Okay. And what X represents is my mean. So I want to find the sample mean. And the way that I'm going to do that is I'm just going to do average. Okay, and I'm going to go over here. If I type in mean, it won't come up with what you want. It might. I know Google Sheets does not, though. So now I just hit enter, and there's my mean of 14.133. So now when I want to just build out the rest of this, I can type it in as an equation and just click all of these values, except I do need this 2.145 to be on its own. And I can click equals this value plus this value times this value. Oh, no, it's not going to do it. Okay. When I do it in Google Sheets, it will do it, the parentheses as multiplication, but this needs a little bit more. So there is a way to do this. Okay. I'm going to do this plus the product of this and comma this. And again, it's not going to let me do it. Sometimes you guys have heard me in past videos talk about just the differences between Google Sheets and, Excel. I'm much more of a Google Sheets person. A lot of companies, though, you will use Excel just because it's a lot, simpler to transition things. But I've grown so accustomed. There is a way to do it. I'm going to show you how to do it, but then I'm just going to use my calculator and I'm going to go over the much easier way. I'm going to use my computer calculator to kind of go through what it would look like. So the way to do this using one line is I would do sum. I'm going to do my mean, comma, product of this times this. And if this doesn't work, I'm going to get very frustrated. Okay, it worked. There we go. The upper limit of what I would expect a customer to get would be about $17.03. Okay, and if I can, go through and shorten that a little bit, that would be the upper limit of what I would expect someone to spend based on this sample of purchases at a McDonald's. Now, let's say you don't want to go in through and type all of that data in there. You can definitely just use a calculator, okay? And what the calculator is going to do, all right, is we're going to do T star 2.145 times 1.35177. I'm just going to use a couple of the sevens. 2.899. Okay, I'm just going to remember that number. All right, and I'm going to do 2.899. All right, 14.133 minus 2.899. And there's my lower limit, much faster than I did it. You're trying to type in all those formulas and stuff like that. Okay, 11.234. And I'm going to round down. So this is my confidence interval, okay? And I would say, based off of what we have, there is the lower limit, and then my upper limit is 17.03 based on this particular sample. I could go in and do an entirely different sample and might get completely different results. But based on this sample, this is what I would expect the population at this McDonald's to have their orders fall between $11 and $17. Okay. Now, what I want to do, okay, is I want to go through a significance test. Okay. Now, the beauty of doing a significance test tied with a confidence interval is a lot of the data that you use is the same exact data. The big difference between the two is with a significance test, I am going to need to insert, okay, my null and alternative hypothesis. So I'm just going to use the characters here because when I try to put in equations in Excel, it doesn't necessarily look nice like my Google Sheets. But this null hypothesis is always going to be the mean is equal to some value. Now, the value I'm going to use is one that I'm going to pick out of thin air. Okay, you guys saw in module 7, I believe, okay, when we did significance testing based on normal data, you basically are just given the value of your hypothesis, and you guys did a pretty good job with that. So I'm not too concerned about our ability to kind of come up with that info. What I want to know here, okay, is that sample mean of 14.133 greater than, let's say, $12, okay? Can I go into McDonald's and would I expect it to be significantly greater than $12? Let's say 11, okay, because it's within the sample mean, but at the lower limit, so that's good. So I want to know if I go in, is it going to be significantly greater than $11 based on this sample data that I have? Now, what I know about the significance test is it's very similar to what I just got done doing with the normal distribution. The problem lies with the fact that I now need to use a degree of freedom when I'm looking for the t statistic. So I'm going to do a lot of the same stuff. So I'm going to do x bar minus my hypothesized x value, which means I'm going to do the 14.133 minus the hypothesized value, which is 11. Then I'm going to divide that by the 1.35 number. okay? And what I should do, okay, just so you guys can clearly see it, okay? This is the problem that I'm doing. So I'm just going to use my calculator. I'm not going to try to type this all in, okay? I'm going to do 14.133 minus 11, and then divided by 1.35. And what I get is 2.32. Okay. So this is my t statistic, but I have to remember I'm doing this with a t distribution, so it's going to have a certain number of degrees of freedom. Well, we already did the degrees of freedom for this problem. There was 15, so we did 15 minus 1 to get the degrees of freedom, and we found that there were 14 degrees of freedom. Perfect. So now what I'm going to do, okay, and this is where it gets a little bit tricky. And I really wish, there was kind of a better way to do this with Excel. I haven't figured it out yet. I've been toying around with a bunch of different functions and things like that. I'm going to say it's a lot easier to just go ahead and use the table, because I think the table does a pretty good job at kind of explaining it. So what I'm going to do, okay, is I'm going to go right to the 14. Why am I not going to the bottom row? This is based on confidence levels. That's only for confidence intervals, okay? Instead, what I'm going to do is I'm going to go to the 14. And then I'm going to go right. And I'm going to go until I see something of that relates to that 2.32. Well, I can see that it falls between these two right here. What I'm going to do is I'm going to use the one left. Why? It's smaller. I always want to round down to be conservative. So what I'm going to do is, if it's 2.32, I'm going to use the 2.145. And again, the reason why I'm going to use that 2.145 is, again, it doesn't fall exactly where it should. And typically they don't, so you need to make a decision there. Like, for example, if the t value I got back was 2.65, again, now it's in between these two, I'm going to round down. If it's really close to 2.56, I am aware of where they are. So when I grade, I'm a little bit more lenient when it comes to picking out the p values. So now what we need to do is, now that we're making a decision to use this 2.145, I'm going to go up. And I have to make a decision, do I have a one-tail test or a two-tail test? How do I know that? One-tail tests are always less than or greater than. Two-tail tests are when it is different or not equal to. So since it is greater than, I'm using a one-tailed test, and the one-tail says the p-value is 0.025. So the p-value here is 0.025. We'll stick with our alpha level of 0.05 like we've been using all along. And now I'm just going to make a decision. That value is less than, so that means we're going to reject the null hypothesis. And that means the value is significantly larger than the $11 we hypothesized. Sorry, I was searching for it there. Okay. And that's how you'd run a significance test. Now let's just take, for example, okay, let's look at, what if I did do a two-tailed test? What would happen here? So what would happen is, okay, all of a sudden now our null hypothesis is still going to be the mean equals 11. Remember, our null hypotheses don't change all that often. Okay, and our alternative hypothesis this time is mu is not equal to 11. All right, again, I can't in Google Docs, I can do a pretty good job with like the not equal sign. I'm perfectly fine with you guys just writing not equal to for the alternative hypothesis. I know what you're writing when I see it. Everything is going to stay the exact same, okay? This is all going to be the same, okay? We're going to get the same values here, but the p-value is where it differs, okay? Because now what I am doing, got to get rid of that. There we go. Okay, is now I do end up with a two-tail test, and now I've got that p-value of 0.05, and now I can see that the alpha level of 0.05 and the p-value, they're equal. So in this case, what would I do? I would just call it inconclusive. This doesn't happen all that often, but it can happen. And what we would just say is inconclusive at best. Okay. All right, so that's how you would do it. Again, if you have some sort of graphing calculator, the TI-83 or anything newer, they all do this test, and I would recommend looking up how to do it. I'm not going to do it here simply because not all of us have it, okay? And I don't want to, do something that not all of us have. All of us have Excel, so I think that's only fair that I go through and do that. Or, there are T distribution calculators. The only thing is you got to be really careful because a lot of those T distribution calculators online, what they'll end up doing is they'll end up feeding you normal distribution data, not T distribution data. So it ends up getting very tricky in that way. Okay, so I've got one more video to do. That is going to be based on 2 sample data. Does get a little bit trickier with the formulas, but I'll kind of walk you through Excel and how to do that. Okay, so just pay attention for the next video.